we have found the Higgs boson. So then the next question is, what's next? Well, the Large Hadron Collider, this machine that is 27 miles in circumference, costing $10 billion, is big enough to create the next generation of particles. So the Higgs boson, in some sense, is the last hurrah for the old physics of what is called the Standard Model, which gives us quarks and electrons. The new theory is going to take us into dark matter. Now, we know dark matter exists. Dark matter is invisible, so if I held it in my hand, you wouldn't see it. In fact, it would go right through my fingers, go right through the rock underneath my feet, and go all the way to China. It would reverse direction and come back from China all the way here to New York City and go back and forth. So dark matter has gravitational attraction, but it is invisible. And we are clueless as to what dark matter really is. The leading candidate for dark matter today is called the sparticle. The sparticle is the next octave of the string. Now look around you. Everything around you, we think, is nothing but the lowest vibration of a vibrating string, the lowest octave in some sense. But a string, of course, has higher octaves, higher notes. We think that dark matter could, in fact, be nothing but a higher vibration of the string. So we think that 23% of the universe, which is the dark matter's contribution to the universe, comes from a higher octave of the string. Now, the Standard Model, which we have ample verification of, only represents 4% of the universe. So the universe of atoms, protons, neutrons, neutrinos, that universe only represents 4% of what there is. 23% is dark matter, which we think is the next vibration up of the string. And then 73% of the universe is dark energy. Dark energy is the energy of nothing. It's the energy of the vacuum. Between two objects in outer space, there's nothing. Nothing except dark energy which is pushing the galaxies apart. So when people say, if the universe is expanding, they say two things. What's pushing the galaxies apart? And what is the universe expanding into? Well, what's pushing the galaxies apart is dark energy, the energy of nothing. Even vacuum has energy pushing the galaxies apart. And then what is the universe expanding into? Well, if the universe is a sphere of some sort, and we live on the skin of the sphere, and the sphere is expanding, what is the sphere expanding into? Well, obviously, a bubble, a balloon, expands into the third dimension, even though the people living on the balloon are two-dimensional. So when our universe expands, what does it expand into? Hyperspace, a dimension beyond what you can see and touch. In fact, string theory predicts that there are 11 dimensions of hyperspace. So we're nothing but a soap bubble floating in a bubble bath of soap bubbles. And so in some sense, the multiverse can be likened to a bubble bath. Our universe is nothing but one bubble, but there are other bubbles. When two bubbles collide, that could merge into a bigger bubble, which could be the Big Bang. In fact, that's what probably the Big Bang is. Or perhaps a bubble fissioned in half and split off into two bubbles. That could be the Big Bang. Or perhaps the universe popped into existence out of nothing. That is also a possibility. And so the universe could essentially be nothingness, which was unstable, and created a soap bubble. Now you may say to yourself, well, that can't be right, because that violates the conservation of matter and energy. How can you create a universe from nothing? Well, if you calculate the total matter of the universe, it is positive. If you calculate the total energy of the universe, it is negative because of gravity. Gravity has negative energy. When you add the two together, what do you get? 0. So it takes no energy to create a universe. Universes are for free. A universe is a free lunch. And then you may say to yourself, well, that can't be right, because positive and negative charges don't cancel out. Therefore, how can the universe be made out of nothing? Well, if you calculate the total amount of positive charge in the universe, and calculate the total amount of negative charge in the universe, and you add it up, what do you get? 0. The universe has 0 charge. Well, what about spin? Galaxies spin, right? But they spin in all directions. If you add up all the spins of the galaxies, what do you get? 0. So in other words, the universe has 0 spin, 0 charge, and 0 matter energy content. In other words, the universe is for free.